Hello, Year 9. We're going to continue with our energy topic today by looking at how we generate electricity in large power stations that burn coal, oil and gas. Coal, oil and gas are non-renewable energy resources. The picture on this slide is of Drax power station in South Yorkshire, which is one of the biggest power stations in Europe. It burns coal and other fuels to generate electricity, and in today's lesson I will explain how that happens. So this is what the inside of a power station looks like. It's a diagram to show the key features of a power station. Most of the big power stations in the UK, well, they burn coal. So what we start with is truckloads or train loads of coal arriving. Literally could be hundreds of trucks every day. It could be train loads every day. The big power stations burn a lot of coal, and coal contains chemical energy. Okay, the coal is put into the furnace. The furnace is very hot. Coal is burned in the furnace, and the chemical energy becomes thermal energy. That becomes thermal energy. Now, that thermal energy goes into a water supply. So we've got cold water coming through here, and as it comes into this sort of bendy pipe here, the heat from the burning coal superheats that water and it becomes steam. So in this pipe here, which is coloured in red, in fact that doesn't contain water anymore, that contains steam. The steam goes into a turbine. So this area over here is called the turbine. Okay, the turbine has got blades, a bit like propeller blades inside, but there's many more of them all packed together, and they start to spin very quickly. Okay, so the hot steam, the thermal energy in the hot steam becomes kinetic energy in the rotating turbine. The turbine shaft is connected to a generator over here. Oops, sorry, I should do that in black. That is connected in to a generator over here. The generator starts to spin very quickly as well, and the generator generates electrical energy. Okay, so we've got several stages here, several stages by which energy is transformed from the chemical energy in coal and it becomes the electrical energy, and that is transmitted on these pylons. These are the pylons here, and this is what we call the national grid, and that is transmitted across the country. Okay, you've also noticed these massive chimneys. You've got these big chimneys here and here. Okay, now what these do, these are used for condensing the steam back to water. Okay, so condensing steam back to water. Sorry about my writing. Okay, that's what they're for. So it's not pollution coming out of those big chimneys. The pollution comes out of this chimney here. This is where the pollution is, and we've got pollution coming out of there. We've got lots of smoke, and that contains carbon dioxide and it contains sulfur dioxide. Okay, and those things are pollutants. So you need to become familiar with how this power station is working. One of the ways to help you is to look at this animation. I quite like this animation. So let's start again. Let's look at how this works. I'm not sure my pen will write on top of this, but we'll see. It does. Coal comes in over here. Coal goes into the furnace, which is here, and it gets very hot and it heats up water. The water becomes steam. So this is the steam in here, and this is water coming in down here. So water turns into steam. That goes into the turbine. That's the turbine there. Turbine is connected to a generator there. Oh, my writing has really deteriorated. Sorry about that. That's the generator that produces electricity here, which goes on the national grid. The steam that was in the pipe has to cool down before it can go back in again, and it goes through a condenser here, and that condenses back from steam back into water again. Okay, so that's quite a nice animation there. You probably can't read any of my writing, but at least you've heard me say it. So we've talked about all of these energy changes. You need to learn all of these. Chemical energy is stored in the fuel, which is coal. Coal is burned, becomes hot, heats up water to become steam. The steam is storing thermal energy or heat energy. The steam, very hot steam, drives a turbine. The turbine spins and it stores kinetic energy. The turbine is connected to a generator, and the generator produces electrical energy. Okay, so we've got all of these energy changes taking place. At each stage, some thermal energy is wasted. Okay, so each stage, thermal energy is wasted. Okay, so it's not very efficient. We'll look at the efficiency in a minute. So this is what we call an energy flow diagram. So for every 100 joules that goes into the power station, so we've got 100 joules over there, only 30 is usefully transferred. So this is the useful. So let's write that on there, useful. And that's electrical. Okay, so it's not very clear. I'll try and do that with that is electrical. All of these other types here are wasted. So we've got 60 joule wasted as heat losses to the environment, 5 joules is used up in the power station, 5 joules is lost in transmission. So the total loss is 70 joules for every 100 that goes in, 70 is wasted, only 30 is usefully transferred as electrical. So if we put that into the formula for efficiency, whoopsie daisy, let's get rid of that. Let's use the green highlighter. If we put that into this formula over here, we've got 30 is the useful output, 100 is the total input. We get 0.3. The efficiency is 0.3. We can convert that into a percentage by multiplying by 100. So coal-fired power stations are very inefficient. Only 30% of the chemical energy in the coal ends up becoming electrical energy at the end. The rest, most of it, is wasted as heat to the surroundings. There are other problems with fossil fuels. When we burn coal, oil and gas, we get carbon dioxide produced. Carbon dioxide causes global warming, and we've discussed that in a previous video. That's causing global temperatures to rise, projected 5 degrees by the end of this century, which is causing the ice caps to melt, the sea levels are rising, and that's going to cause flooding. Things like weather systems are becoming much more extreme and unpredictable. We also have sulfur dioxide being released. Now, sulfur dioxide it mixes with rain up in the atmosphere, and it becomes acid rain. Acid rain is destroying the natural habitat. You can see here a forest in Scandinavia that's been destroyed by acid rain. So two separate problems with burning fossil fuels in power stations. How is coal formed? Coal is a non-renewable energy resource, which means that once we dig it up and use it, it will not be replaced. And the reason for that is that coal formed millions and millions of years ago. It takes millions of years to form. It's formed from trees that died millions, hundreds of millions of years ago, fell into the ground and was covered up with layers of silt, and pressure from above over millions of years, pressure and heat have turned the remains of those dead trees into coal. So we've used up most of the coal. It cannot be replaced quickly at the same rate that we're using it. It takes millions of years to replace that coal. So that's why it's non-renewable. So I'm going to write that there. It's non-renewable. Oopsie daisy. Oh dear. It's not very... So here is the solution to the problem of burning fossil fuels, and we discussed these in a previous lesson. Here are the renewable energy resources that the world is moving to. We're trying to not use coal, oil and gas anymore. The UK is moving away from coal-fired power stations, and we're building a lot of wind turbines and solar panels, and different countries are doing different things depending on what they have available in their country. So this is the future. You need to be aware of advantages and disadvantages for each of these types of renewable energy resource. Okay, and you also need to know how a power station works. You need to know what the problems with it are, and you need to be able to work out the efficiency of a power station as discussed in this video. Please have a go at the mini test on its learning. In fact, I'm going to put an assignment there for you to have a go at. Thank you for listening, and if you've got any questions, please send me a message on its learning. Thank you very much.